Hi everyone. In this video, we're going to build a PDF chatbot using a method called Retrieval Augmented Generation. We're going to use pre-trained LLMs to interact with complex PDFs on a computer. We're going to do this thing exclusively on Google-Colab with a T4 GPU. And a complete tutorial on this thing can be found on my GitHub repo. You can follow the link, which I will also share in the description below. So we're going to discuss the theory first. We're going to start with the theory, and then as we progress, I'm also going to demonstrate the method to build a PDF chatbot using RAG. Basically, it's going to be a hands-on tutorial. So let's jump into it. So what is retrieval augmented generation? It is, as I said, it is a method which follows 3 steps. So there is retrieval, there is augmentation, and there is generation. Retrieval is where you retrieve information from a data source. This data source can be PDF, it can be Word documents, it can be HTML pages. So you retrieve information from these documents, and then this entire information is broken down into chunks. So if you have pages and PDFs which have around 300 words, you can break it down into chunks of 100, 200, or any size that you desire. You can break the text down into smaller chunks of tokens, so to say. Once this entire text is broken down into chunks, it is vectorized. There is embeddings created out of these chunks. So the number of chunks or number of document chunks that you have here will be equal to the number of embeddings that are created here. So we create a so-called embeddings database in the process. And then you have this human asking a query. So again, this query is also first converted into an embedding. Query or a prompt is converted into an embedding. And this is where the augmentation part of retrieval augmentation generation takes place. So you augment a prompt and a context. And this, how is this context generated? Amongst the embeddings available in this database, only the ones that are relevant to the question that the user asks is fed forward. So for example, if you have hundreds of documents, one discussing about, let's say, a sport, another discussing about, let's say, finance, and if you're going to ask a question about the sport, only the embeddings relevant to the sport will be fed forward. And then, so you have a prompt embedding and you have the context. So this is where the augmentation takes place. And then once you feed this input to a large language model, then this model generates language. This is where the third part comes into the picture. Generation part of retrieval augmentation generation and the model response. And this LLM, in our case, we're going to work with Mistral, and the framework for doing vector indexing and other things, we're going to be using LlamaIndex packages. So I hope the method is clear. The approach is twofold. There is context retrieval and there is text generation, as I described above. The advantages are that data privacy is intact. You can literally build this chatbot on your local environments, on your on your computers, and the large language models, since they're hosted locally, there is little scope of your data being leaked. And then there is no commercial API-based costs associated, right? So in this cell, we essentially capture the time of every cell that runs. We just want to see how the model performs and how the efficiency is. And from here onwards, we start the tutorial, we start the demo. So we install some dependencies. These are necessary so we install upgraded transformers, we install upgraded bits and bytes. And as we progress, I'll tell you why these are necessary. Here is where we install LlamaIndex packages. Yes, so we do certain imports, and then since we're using Mistral model is hosted on Hugging Face, and then we need a Hugging Face login or a Hugging Face token to proceed forward. So we do from Hugging Face Hub import interpreter login. And once you do this, you will be prompted to feed a token. And that's a token that you can get from your Hugging Face account. I mount my Google Drive on this notebook because that's where my PDFs are stored. So let's say I have these two PDFs which I want to feed to my chatbot, and I start asking questions. And deliberately, I've chosen two PDFs that are not available on the internet. So one is a UN reforms essay that is personally written by me. I can show it to you. So I discuss about United Nations security. Like I discuss about the topic whether the UN Security Council needs to be reformed. And this is absolutely my views. So I have basically used this essay as one of the PDF that I want to interact with. And then I also have a second document, which is anecdotes from my IIT-JEE preparations. So I feed that also in the chatbot. And as we progress, like towards the end, when I'm about to conclude the demo, I will ask questions, two separate questions, one from each of the PDF. And then I will also demonstrate how the chatbot picks the context from the relevant PDF. So I place my PDF in Google Drive, and I mount my Google Drive on this notebook. So a little bit about the Mistral-7B Instruct model that we're going to use. This model is state of the art. It was released by MistralAI in the second half of 2023. This model can be persisted locally. You can have the weights and weight files downloaded on your computers. The model is fairly small to work with, so it is very convenient. Parameter count is 7 billion as compared to ChatGPT, which has around 175 billion parameters. It's a huge model. The context window for Mistral model is 32.8K tokens, so it is sufficiently large for our use case. It requires minimal GPU for inferencing. As you can see, we're working on Google-Colab, so it works absolutely fine on Google-Colab. Fine-tuning, if we perform fine-tuning at all, although we do not do it here, if we need to do that, it is also not very computationally expensive. And since it is open source, there is a good amount of community support available. So yeah, so we perform quantization. We try and load the model in lower, like the weights of the model in lower precision, so that we can interact with model on a smaller GPU. Settings is something that we are importing from LlamaIndex packages. So this is where we configure this is where we tell the chatbot what models we are going to use, what LLMs we are going to use, what all specifications we are going to tell. So for example, we're going to be using this model. We define it here. We also define the tokenizer name. We tell model that our context window is going to be this, and the max new tokens that you're going to throw out is 256. So the model will not respond beyond 256 tokens. We can control these. These are parameters that we can control. And then I also define other parameters. So here I'm asking the model to do sampling. It basically makes the output more varied and less deterministic. I control temperature. I control top K parameters. I control top P parameters. So basically, by defining top K equal to 50, the model will only consider top 50 most probable next tokens. By model, I mean the large language model. And by defining top P equal to 0.95, the model will choose from the smallest set of tokens whose cumulative properties or probability is 95%, at least 95%. And then I also specify the embeddings model that we're going to use. It is again coming from Hugging Face, and it is defined like this. The name of the model is BGE small n version 1.5. So this is where the model gets loaded. And next, we set up a prompt template. So now we're going to essentially talk to large language models. So we're going to have an interaction with these models. So we need a template to convey our messages to the model. So first of all, we let the model know that hey, you know what, you are a well-behaved chatbot, aka a Q&A assistant. And your goal is to answer questions as accurately as possible, exclusively based on the instructions and context provided. So this is very important. Like we want the model to restrict its response to the context that is there in the PDF. Otherwise, there is a plethora of information already available to large language models, pre-trained LLMs, so they can basically throw out that information, but we want the model to only stick to the context that we're feeding. This is where the context gets appended, and this is where the user query gets appended. So this is a format in which we basically interact with the model. We store this information in a template called text QA template. Next, okay, so by this method, by this line, we are loading our PDFs. So we define a document path, which is PDF path where my PDFs are stored, the folder path, and this is now loaded in the object called document. And now let's see what's inside this document. This code below this is basically exploring what lies within the object document. So as you can see, there are two files that are processed. One is anecdotes from my ITJ preparation, and the other one is UN reforms essay. And the first file has 3 pages. The second file has 4 pages. 4 pages. Cumulatively, we are discussing 7 pages, but in our day-to-day life, PDFs can be much larger, and this chatbot, this system deals with it fairly easily. So now we do this. Now let's try and create a vector embedding ZB. Let's try and achieve this state right now. So the next thing that we're going to do is called indexing. So we have the PDF. Now we want to break it into chunks, and we want the chunks to be stored as an embedding. Not as an embedding, but as embeddings, multiple embeddings. So we create something called vector index. So we feed documents, we feed our document object here, and vector index is created like this. And in order for us to see what lies in this vector index, I also provide a code here. So I'll be sharing this notebook. I'll be sharing the link to the GitHub repo, so we can easily duplicate this code. But let's see what happens when vectorization or indexing takes place. So as you can see, this page 1 from this document has been indexed into 2 nodes. So basically, the information available on page 1 of this document has been broken down into 2 nodes, into 2 separate chunks or embeddings. Second, information available on the second page is broken down into 3 nodes. Information available on the third page of this document is broken down into 3 nodes. So similarly, you have the second document, which was the UN reforms essay, which had 4 pages, and these 4 pages are broken down into these many nodes or these many embeddings, right? So first page of this essay is broken down into 3 chunks. The second one is also in 3 chunks or embeddings. The third one is also 3 embeddings, and the fourth one is stored as one single embedding because there is lesser text on the 4th page. So this is where we achieve this stage. Now we have our embeddings database. So we move on, and now we define something called query engine. Our method of interacting with the LLM, given it also looks at the context that we have provided, when it also looks at these vector embeddings. So here we define something called chunk size and chunk overlap. So what we want the model to do is, we want the model to pick one chunk at a time that does not go beyond 512 token. The size of the chunk should not exceed 512 token. And the overlap. So basically, if you're breaking down a PDF into multiple chunks, there can also be some overlap between the end of the first chunk and the start of the second chunk. So we would want some tokens to be common so that we do not miss out on information, or the context between two different chunks is not absolutely discrete. So if we break down a PDF into multiple chunks, we would want some overlap between these two chunks so that the information between these two chunks, as I said, is not discrete. There should be some continuity. So we take an overlap of 10 tokens. And number of text chunks that we want to be considered in one single prompt is 3. So this is also something that we can control. So we would, if we ask a question to the chatbot, we would want that chatbot breaks down the chunks into these many token counts. Second, every chunk should have an overlap of 10 tokens, so there is continuity maintained. And for every question that we ask, the model should take top 3 relevant chunks, right? So if you're feeding, let's say, 7 pages, we're feeding 7 pages to the PDF, and these are broken down into these many chunks, we would want the model to take top 3 most relevant ones while it responds. We would want top 3 chunks to be considered for generating the context for large language model. I hope that's clear. Then we define this query engine. We set a response mode as compact. This means that the query will generate very precise, to the point. It will avoid lengthy and detailed explanation. It will generate to the point responses. And we choose similarly to top K as this particular number. And then the text keyword template is something that we defined above, right? So that's also taken into consideration. And then the good stuff, we start interacting with model. So we feed in human queries. So the first question that I ask is, hey, what stats about IIT-JEE are discussed in this document? Give me answer in bullet points. And the model responds. The response of the model is collected in this object response. And then this code is where we basically dive deeper into what is being collected in the response thing. So, the model response, IIT-JEE stands for Indian Institute of Technology Joint Entrance Examination, which is the toughest engineering exam. It is conducted by IITs and sees participation from 485,000 students. Let's see if this information, we in a minute, we will also see if this information is actually present in the document. The success rate is 1%. Almost 3/4 of India's 100 unicorn startups have at least one founder from IIT. So the model actually responds. And what we are exploring within the object response using this code is the following. So the model says, hey, I've taken these 3 sources in the context for responding to the query that you have asked. And these 3 sources are as such. So this document, so first of all, I'm looking into this document, page number 1. It has a similarity score of 0.793 with the query that you asked. So it, according to the model, this particular information that I display in row number 1 matches the query that you have asked by a score of 0.79. So in this particular document on page number 1, from starting character index 0 to ending character index 1035, this text is available, and this text is very much relevant to the question that you asked. So, hey, human, this is the most important information that you're seeking through the query that you've asked. The second most information is present on this, again in this document, page number 1, and from this character till this character, the text is this. And again, so the third most information similarly is available again on this PDF on page number 2, but that has the slightly smaller similarity score, which is 0.741. And the text available from this index to this index is the following, and that contributes to the answer that you expect. So let's just quickly see if this information is true, right? So I will quickly open anecdotes from my ITJ preparation. So as you can see, model has responded that, like there are 485,000 students, and most of the responses coming from page number 1, right? So page number 1 essentially has this information, right? So we've seen 373 of India's 100 unicorn. There's something that model also says, right? Here. And then, yeah, so about the 485,000, this information is also present on page 1. And there's also information on page number 2. But the model is mostly interested in page number 1. And the model is mostly interested in responses or information available on page number 1. Now, let's see if the model, now let's ask a second query to the model, okay? This time the query, I'm going to focus it on the second document, and let's see the model really identifies, hey, you know what, this time I'm going to respond from the second document. Let's see if the model does that, okay? So I'm going to feed a next query, which is the following: what key points has the author proposed for the UN reform, for the reform of United Nations? Answer in 3 to 4 lines. We wait for the model to respond. Yeah, so we have it. So the model says the author proposes the following key points of UN reform. The UNSC should be reformed to ensure all regions are represented, with a focus on the P5 nations' ability to contribute to international peace and security. UNSC is relevant to modern international security should be emphasized. The US is ambivalent about UNSC reform, with concerns about the size of the council and the behavior of new permanent members, particularly major developing democracies. So what is really interesting here is that the model this time says that I'm going to pick the top 3 information only from this file, right? So it says the most relevant information is available on page number 1 in this essay, and the score is 0.701. The score is again the similarity score between the query that I asked, the user asked, and this particular text that the model found, this particular chunk of text that the model found in somewhere in the PDF. It says that on page number 1, from 1148th character until 2281th character, the following text exists. And hey, I think this is the most relevant text to the query that you've asked. So as I said, like the really smart and the really interesting thing to notice here is that the model is only taking context from this document, even though it is being fed even though it is being fed 2 documents with 3 and 4, 7 pages, but the model will narrow it down its search to only this document because the query that we asked was relevant only to this document, right? So this is how RAG works, and it's quite fascinating. I mean, having this power at your disposal to interact with your PDFs, you can basically interact with your legal PDFs. You can work on terms and conditions that you come across for various products that you use. You can basically feed it to a RAG chatbot and ask super necessary questions, like, and it saves your time, right? You can if you work with complex financial PDFs, RAG is a very important RAG can be a very important tool at your disposal. Yeah, so if you read if you don't want to read larger news, or if you have magazines as PDF, you can basically feed it to a RAG chatbot and have summarize information at your disposal. So this is really, really fascinating tool. And yeah, that's it for now. And I'm going to be attaching the link to the GitHub repo under the description. Yeah, I hope you like the video, and thank you for your attention.